Okay, picking up where we left off in part number one, we finished the top plate, and we are gonna move on to our second part, and this is where I think it becomes clear what the top-down workflow is going to be. So we, it's going to make more sense with this workflow if you're building parts successively that have mating conditions. It's not required, but it just kind of makes sense, and you'll see why. So the parts that mate, or the part that mates to the top plate, is the axial support. On the axial supports on the left and right hand side. There's two of those. And what that's going to do in a top-down approach is to give us geometry that we can build our part from. Okay, so understand that in this kind of scenario, we have the axial supports right here is going to be fastened to this surface on the top plate. The geometry is a mating type of geometry. It's surface to surface. And we're going to be able to take that geometry that we've already developed in the top plate, that we've already sketched and constrained, and we're going to use that geometry in our creation of the axial support. So let's get started. All right. So we're gonna have a go with the axial support. Let's switch our view here. We'll kind of look underneath, and I'll draw this. I guess we could call this the right side axial support. I'll draw it from there. And the first thing that I want to do, okay, and this is super important. I mentioned this in part one, but we weren't, because we were only dealing with one part. We weren't really able to see how it plays out. But I want to make sure that I go to the highest level of my assembly hierarchy. Okay, so in other words, I'm going to build a new component, right? I'm going to start working on the axial support, and that's going to be a component or a part. What Fusion calls them components, but they're really individual parts of the assembly. If I create a new component with my top plate highlighted here, or active, then what I'm going to be creating is a subcomponent under the top plate. So from a hierarchical point of view, the caster assembly is the highest point on the hierarchy. It's the top of the hierarchy. All the components that I'm going to draw, the top plate, the axial support, the wheel, the axle, the bushing, are going to be subcomponents under the caster assembly. So when I create my next component, my axial support, I must make sure that my caster assembly is the active component, because the components that I make, my new component that I make after that, is going to be a subcomponent of that. So I don't want to create a subcomponent under the top plate, right? We would do that if we had subassemblies. If the top plate was more complex, if it was a subassembly and then we had parts under that, that's not the case here. Okay, so I must make sure that my active component is the assembly. Okay, and now I'm going to make my new component, and we'll go over here and we'll call this the axial support. By the way, it also is a good thing to remember to use capital letters, because the names here will be propagated through to the bill of material when you do your drawing of the assembly. So again, it just saves time. These little things that you can do while you're working will save time in the end. Okay, so we go to like that, and now this becomes kind of grayed out, or the visibility is decreased, so that we can work on that. But we're going to draw here. So what I'm going to do is I want to sketch, right? And I'm going to start drawing my axial support from the base of this surface. So I'm going to go to sketch, and we can still pick these surfaces, right? So I'm going to pick that surface right there, all right? Sometimes they're kind of hard to see, but you know, you can still do that. Notice that the axial support, you can see the level is on the same level with the top plate, right? And they're both under the caster assembly, right? So we go like this. Now, these edges, while they're visible, I want to actually include them in my sketch. They're not included in my sketch right now. I actually want that geometry to go into the sketch. So I'm going to go to Project, and I'm going to just click in the space, and it's going to pick up all those edges, and I'll say OK. And now watch. I'll just show you. I'm going to turn off the visibility of the top plate, and you can see I have that shape in there. Okay, so I don't know why I turned that sideways. Let's go back here. Now, do I need to constrain anything of this? No. It's already constrained because I constrained it in the top plate. All right. So that's it. Finish the sketch. Okay. Now, getting oriented, it might help to turn this back on just so you can see. I want to pull this down. So what I'm going to do is I'm going to go to extrude, and I'll pick this shape right here, and I'm going to extrude it down, and I'm going to extrude it down 10 millimeters. So it's already at 10 millimeters. I'm going to make a new body, right? New body here. Right? It's a body under the axial support. And I'm going to say OK, and then that's it. Right? Now at this point, my axial support is active, which is correct. I'm modeling my axial support. I'm building it, so I need to have that one active. Another thing that this does is it keeps your timeline kind of segregated and appropriated to each of the respective parts. In other words, the timeline that I'm building right now is the timeline for the axial support. In the top plate, if I go and make that active, this timeline is for the axial support. One thing that I've noticed that users can do erroneously is you can build the axial support in the caster assembly, right? We can model that. But what happens is we end up having a timeline that's all mixed up. It has some elements of the top plate in it, some elements of the axial support, and it really makes much more sense from a workflow, from a modeling point of view, to keep the components segregated. So I'm going to work in the axial support here. Right. Now, if it's confusing you to have the top plate on there, we really don't need that, so we can turn the visibility off right there. All right, now let's get the rest of this drawn. I want to now draw on this. I'm going to sketch on this back surface, so we'll go to sketch. We'll choose that back surface, and we're going to sketch, right? So I'll draw a line, and I'm going to go just like this, and I'm going to, whoops, nope, don't want to do that, sorry. Let's go back here, line. I'm going to click on this endpoint, lock it in there, and then I'm going to come out some distance, whatever looks good, and I'm going to click and hold the left mouse button down and go into the arcing mode, and then release and come down here. Okay, that's a really good skill to know in Fusion, and there we go, right? So now we need to constrain it. So let's first do let's first align this. We'll hold the shift down, and we'll get the midpoint here aligned with the center there. Okay, so it's symmetrical. Then we want to get I've heard people say that, yeah, you got to do geometric constraints before dimensional constraints, or vice versa. You know, it's going to depend on the geometry. I'm not going to say you got to do one and then the other. You know, flip back and forth if you need to. You just got to get it done. And this is 19. And we want to make sure that this is tangent. And it's all black, so it's all constrained. We're all good. We'll finish the sketch. Let's go back to a 3D view, and you can see, let's look at it from this vantage point. We'll extrude, and we'll pull this way, and it's going to be -10. All right. So far, so good. Let's put the let's put the back surface on here. There's a boss pad or a face on this. So let's sketch on this back surface, and we'll draw a circle. We'll find that circle, and we'll draw that there, and I'll make that 19. Actually, you know what? I'm gonna do this the smart way, right? I want to link the parts together, so I'm going to, I'll do this. I'll project this into that space, project at the geometry, and draw my circle from there. So by matching it up there, that connects it a little bit more, and then I'll draw this. That's a diameter 38. We're all good to go. Now, if you're wondering why I didn't put the hole in there, I'm going to use the hole command. We could extrude a hole if we wanted to, but I'll just put the hole. I'll just use the hole command, and then extrude this out. And this is going to be 2 millimeters. So 2 millimeters right there. And then finally we'll put the hole in there. And this hole is a diameter of 22. And it's going to go, let's see, distance 2. We'll go to this surface right there. We'll say OK. And last but not least, we just got to put the fillets and rounds on there. So now fillets can be a little bit tricky sometimes. Definitely, I have found that they are order dependent. That is to say, the order that you apply the fillets can make or break you, basically. So, you know, when you're doing fillets, be prepared to go back and to remove them and try again in a different order. So let's see. First thing I'm going to do is let's get this. Let's get this, and that is what are those fillets? Oh, you know, I gotta fix, you know, before I do that, I'm sorry. These holes right here are actually spot faced. So it makes sense that I should do that. So I'm gonna go to the hole command, and I'll put the hole right there. Okay. And the diameter on this is a diameter 20 spot face. The depth of a spot face on a drawing, the depth is not given. If I pull this across right here, you can see this. S face is the abbreviation for spot face. But notice the depth of the spot face is not given. Typically in manufacturing, the spot face is just done to go from a rough surface to a smooth surface so that you have better grip on a nut or the head of a bolt or a washer or something like that, and you can see that right in there. So I'm just going to go down 2 millimeters. I think that is going to be fine, and I would suggest that you do the same. You definitely don't want to go down too deep. So there we go, and then I'll just do the same. Right click, repeat hole. It's nice that it remembers the last one so that, everything goes a little bit easier. All right. Now let's put the fillet in there. Now what are the fillets on that? That is a radius 3. Couldn't find that for a second. There we go. Radius 3. So then let's put the fillet around here, like so. And let's get this side right there. And if we play our cards right, it should all go in one fell swoop. Yep. Okay. And that's it. All right. Spot face eats a little bit into the fillet, but that's by design. And we're good to go, I think. Oh, you know what? There is, this is a good point. There is a round here, and it's interesting how we're going to get that in there. Let me show you. Okay, so remember the offset here is 2 millimeters, right? And we're using a round of 3 millimeters. So if I go like this and do 3 millimeters, is it going to put it in there? It is going to put it in there. All right, so that's and actually what it's doing is it's cutting it off, but that's perfect. That's exactly what we want. Okay, so we go like this. We can look at it. Let's look at the front view. Everything looks good. Can look at the right side view. There we go. Do we have everything? I think diameter 22. Yeah, I think that's it. All right. Let's do our materials. So we're going to go to physical material. This is also malleable iron. So we'll drag and drop it over there. And then we want to work on the appearance. And so we want iron polished, and we want, we need to make this faces, and we're going to attach it to the bottom. The whole, looks like it did the whole thing. Let's go and let's try to go back. I had this problem before where it wasn't updating it properly. Here we go. Okay. I'm not sure whether it's going to let us do this. Let's go to iron polished, and we want to go to faces again, and we want to attach, actually I don't, here we go. I think it was because the whole thing was highlighted there, so I need to get off of that mode. And these are all finished. And last but not least, let's get this bottom surface right here. Okay. And we'll go back to this. We're good. Let's turn on our top plate. And let's go back to our higher level, the caster assembly, and we can click out of this and see what we have. All right. So far, so good. That looks good. Let us let me inspect something right here because I'm a little bit curious about this. What is the distance from here, this edge, to the front edge here? So it's 38 in the drawing. I just want to verify that it's 38 here. 39.85. Okay, so what that means is that me picking up the geometry here wasn't exactly, I shouldn't have picked up all the geometry. All right, so how am I going to fix that? Well, we're going to try to fix it this way. One of the things that Fusion allows us to do is to essentially go back in time. So let me go back to the axial support. Okay, I'd like to say that I did this on purpose to show you, but I caught myself, and the distance should be 38. It's 39.85. The top plate is correct. It's the axial support. Basically, right here, these surfaces should not be mating. Okay, they should be offset by 1.85 millimeters. So what I'm going to do, I go back to my axial support, and I'm going to go to that original sketch, and I'm going to edit that sketch. Okay, what I'm going to do is I'm going to draw a line from here to here, like so, and dimension it from here to here, and that should be 38. That is 38. You know, I think what I may have done accidentally is measure the wrong surfaces. Yeah, let's measure it here. Maybe I did it right. Who knows? Let's go to a higher. Let's go from, let's just get rid of the axial support, and we'll measure it from here to here, and it's 38. Okay, so never mind. I did do it right, or it is correct. So we don't have to go back in time. But we do have to mirror this. All right, so mirror is under the create menu and mirror. Okay, we want to make sure that we are at because we're creating a new component, we want to make sure that we're at the top level, right? If we create the axial support, the left side of the axial support, while this is highlighted, we'll be creating a subassembly of the axial support. We don't want to do that. All right, so we go to the higher level, and we go to create and mirror, and I'm going to just pick, well, let's see, we can pick component, and I'll pick that component right there. All right, now the mirror plane, this is where thinking ahead and getting the origin and plane set up for our model makes sense, because now when I go to select my mirror plane, I can use that as my mirror plane, and there we go. Everything is good. We say OK, and notice what it created over here. It created a second component that's a mirror image of the first one. Okay, so there we go. All right. Okay, so that's part 2, the modeling of the axial support, and in the next video I'll work on the remaining parts, kind of building them from contact surfaces. So the next part that I'll work on is going to be the bushing and then the axle, and maybe I can get, since those are kind of simple parts, maybe I can get both of those done in the video. And then the last thing we'll do is the wheel, and then we'll also look at how we can get the parts in from McMaster Carr, the nuts and bolts and washers and all that good stuff. Okay, so I'll see you on the next video.